What is small, square, and make sure that your PV energy is going into water heating? Not the most difficult question, and you guessed absolutely right, the Fronius Ohmpilot. This is the device we are talking about today. A very warm welcome to the webinar, Ohmpilot set correctly from day one. We will look into settings you can do with the Ohmpilot. We will start with the commissioning process and then continue with some specific questions that came from our technical support from the colleagues at our hotline. The first question will be if there are special settings we recommend for summertime and wintertime. Then we will see what you do if there is zero feed in. And last but not least, I will show you some options you can do so that you are feeding in before the Ohmpilot starts working. As always, if you have questions during the webinar, please feel free to ask your questions in the chat. My name is Maximilian Schett and I will do the webinar, and Michael Raunig, my colleague, he will take care of your questions, and he will do this while I am speaking. After the webinar, we will take a few minutes and discuss the most important questions, and even after the webinar, you will have a few minutes when we stay online. The Ohmpilot, as you might know, is our device for using PV surplus for water heating. It is a power regulator that can be connected to ohmic loads. And these ohmic loads are mostly heating rods that are put into the water boiler, but it can also be other ohmic loads. As I said, heating rod, this is the most popular case, but it can also be infrared panels or electric underfloor heating. So you can use the Ohmpilot for heating rooms as well. If it is used together with heating rods, so this is the most popular application, then it might look like this. You see here a graphic of a boiler, a water boiler. On the left-hand side of the water boiler, there's an Ohmpilot, and the Ohmpilot is connected to two heating rods. In general, an Ohmpilot can be connected to up to 2 ohmic loads, so it can be either 1 or 2. It can be a one-phase heating rod or a three-phase heating rod, and it is also possible that one entrance of the Ohmpilot is used for connecting it to a heat pump, an SG-ready heat pump. You will also see in this webinar. On the right-hand side of the water boiler, there's the primary heating. Let's say this is a heat pump. It can also be a gas heating or oil heating. The connected heating rods, they can have power up to 18 kilowatt. As I said, it can be up to 2. Our recommendation is that the heating rod above is a single-phase heating rod, and the heating rod below is a three-phase heating rod. Why to do it this way? In the lower section of the boiler, the fresh cold water comes in, and it is useful if you have a more powerful heating rod in the bottom. The Ohmpilot is usually connected to a temperature sensor. Usually means it is not per se not necessary, but we strongly recommend it. The Ohmpilot is just more fun. If it has a temperature sensor, it just has more features you will also see in a minute. And finally, the communication between Ohmpilot and our inverter happens with Modbus or LAN cable, and it is also possible that the Ohmpilot is communicating via Wi-Fi. So you can choose between those three options. Let's go to the first question. We will start at the beginning of an Ohmpilot live. We will see what to do when commissioning an Ohmpilot. You know there is one button, just one button at the surface of the Ohmpilot, and you can press this button once, twice, or 3 times. If you press it once, then WPS opens, so the connection point for the local network, the Wi-Fi station. If you press the button twice, then the access point opens. This is what we need for the commissioning process. And if you press the button 3 times, then a boost mode starts. This means the Ohmpilot is giving maximum power and so do a maximum heating. For the commissioning process, we need the second possibility. We press the button twice. The access point opens. You can then use your device and computer, for example, to connect to the network, to the Ohmpilot network, and type in the password. The name of the Ohmpilot network will be Ohmpilot _ serial number, and the password is 123456778. You enter that, connect to the network, then you open the internet browser, and there you enter the IP address. And the IP address is always the same with all Fronius products. It's 192.168.250.181. You enter this in your browser, press enter, and then you're connected to the Ohmpilot. And then this surface pops up. You see there are 3 sections you can choose. There's Ohmpilot, the general section, and network. The first surface, Ohmpilot, just tells you the status of the Ohmpilot. So as you see, the temperature and heating output and so on. And this is interesting when the Ohmpilot is running, but for now, for the first settings you do, it's not so interesting. You just go to the second section, to general. And in general settings, you can do the settings for both entrances, for both connection points of the Ohmpilot. So here you see this named as heater 1 and heater 2. And when configuring those 2 heating devices, you have several options, and I will go through them with you. So with heater 1, you can choose between automatic and manual. This means if the Ohmpilot is identifying the heating device automatically, or if you type it in manually. Mostly automatic works. If not, then you do it manually and it's totally fine. If doing manually, you have to choose between single phase or 3-phase, and you have to choose the power. In our case, it's a single phase heating rod with a power of 424 watts. Below you see 4 boxes you can tick. The first box on the very left-hand side is temperature sensor present. So this means is there a temperature sensor connected or not? And the other boxes you can tick, those are only available if this box is ticked, if there is a temperature sensor. So this is what I said before, it only is fun if there is a temperature sensor, you just have more options. Below temperature sensor, you can set a tick at adapt day curve. There you can enter specific periods of time where you want your Ohmpilot to work or to work up to a certain temperature. We will see this in a minute. On the left-hand side, you can choose Legionella prevention. If you set the tick in this box here, then another box opens on the right-hand side, and there you type in an amount of hours. The Ohmpilot then checks if at least every this amount of hours the Legionella temperature is overcrossed. So if the temperature has been higher at any moment. So let's say you enter here 200 hours, then this means the Ohmpilot checks every 200 hours if the temperature has at least risen once. And then you can enter maximum temperature. So this is the temperature the Ohmpilot should maximum heat up to. In this case, it's 50 degrees. And below you can do the settings for heater 2 as well. There now the consumer is turned off, so this means there is no second heating rod. You could also choose here single phase, 3-phase, or heat pump. Then you press save, then this is done, and then you go to this third section to network, and there you just enter the network the Ohmpilot should connect to if it is connected via Wi-Fi. Not difficult, I suppose. then you press Save and Connect, and your Ohmpilot is ready to play. And so now where the Ohmpilot is ready to play, let's go to some specific settings. One question that our support is asked frequently is, are there specific settings for summer and for winter? Is there any recommendation that Fronius is doing that you should differentiate between seasons? Our answer is basically no. We prefer universal settings, so one type of setting that holds for summer and for winter. Why just one setting? There are two reasons. First of all, there's not a lot of optimization you can do. You will also see some options you can enter, but the amount of it's not that useful that it compensates for the additional effort that you have to do and also your customer has to do. What do we recommend? So again, you see the graphic of the water boiler, the Ohmpilot, and the heat pump or the primary heating. And we recommend that you enter your primary heating, that it is going up to a temperature of maximum 45 degrees Celsius. And the Ohmpilot is allowed to heat up until 60 degrees Celsius. And then we enter, you remember this tick you could set at adopt day curve. And then we enter a particular period of time where the temperature should be at least 45 degrees Celsius. And this period of time is between 4 p.m. and 6 p.m. So the Ohmpilot is using all the time PV surplus for heating water. But between 4 p.m. and 6 p.m., it makes sure that it is at least 45 degrees. If it is not, then still the Ohmpilot activates the heating rods and uses, if necessary, electricity from the grid. What does this mean in winter? So in winter, your primary heating will heat up anyway, and the temperature of water will be more than 45 degrees at 4 p.m. So usually the Ohmpilot will, between 4 p.m. and 6 p.m., not activate and not do additional work. The maximum at 60 degrees Celsius is set because there is a problem, there can be problems with lime. If you have a very lime-rich water, then above 60 degrees Celsius, it is likely that the lime stays in the boiler and at the heating rod, and that it damages the system over time. If you don't have lime-rich water, if there is a very low degree of lime, then it can also be possible that you can set this maximum temperature higher. If you're considering this, please check with your water installer. He should be informed about what is possible and what not, and it's always a good advice to go with your heat pump if you have one. So this is in winter, and what is in summer? In summertime, the primary heating is usually turned off, so it doesn't do any heating, also not water heating. And only the Ohmpilot is doing water, and usually the Ohmpilot will have enough surplus so that the water is above those 45 degrees. So also in summer, this specific time period between 4 p.m. and 6 p.m. will not do any difference. It will only do a difference if there are very rainy days, if you have 3-4 days in a row with no sun, and then it can happen that the temperature of the water is lower than those 45 degrees, and then the Ohmpilot heats it up so that at least a person can take a shower in the evening, for example. So this is the universal setting. Let's take a look at the settings of the Ohmpilot, how you can do this. You see here again, general settings, second category, general. You see those are the options for heater 1. We ticked temperature sensor. We ticked this time adapt day curve, and also the maximum temperature is ticked. Maximum temperature is set at 60 degrees. As I said, that's the recommendation. And at that day curve, we entered this slot from 4 p.m. till 6 p.m. and a temperature of minimum 45 degrees. Let's go to the second question, how to proceed with zero feed-in. Zero feed-in means that your customer is not allowed to feed in any electricity. So what does he do? He will try that his self-consumption rate is as high as possible, so that he is consuming as much as possible from the electricity that comes from the roof and is feeding in as little as somehow possible. What can we do? So first of all, we could increase or extend the window where the Ohmpilot is working. We could decrease the maximum temperature of the primary heating to only 40 degrees Celsius. We wouldn't recommend to go below 40, because below 40 showering will get a bit cold. 40 is still okay, so maybe also a matter of taste, or if 40 or 45, but 40 is good. And as I said, if it is possible water-wise, then we could increase the maximum temperature a little bit and up to maximum 80 degrees Celsius. For owners of heat pumps that are SG ready, there's another option. SG ready, maybe you have heard it. SG ready is a communication standard, and if a heat pump fulfills this communication standard, it can be connected to our Ohmpilot. And then it looks like this. The Ohmpilot is connected to a heating rod. That heating rod is above in the boiler. And below there's not a second heating rod, but with the second entrance to the Ohmpilot, it is connected to an SG ready heat pump. The heat pump can then be configured so that it is switched on at a certain amount of surplus and is switched on at also a certain amount of surplus of electricity use. This is also an excellent opportunity for increasing self-consumption. How do you do this? We again connect to the Ohmpilot and go to the general settings. You see a screenshot. In this screenshot above, you see the settings for heater 1, and below you see the options for heater 2. This time for consumer, we do not select one phase or three phase, we select SG ready heat pump. And then you can enter a starting threshold and a switch off threshold. We recommend to set the starting threshold at the amount that the heat pump needs, so that the heat pump starts running if it can be run solely by PV surplus. In our case, we say this heat pump has a power of 2000 watts. So if there is surplus of 2000 watts, please switch on the heat pump. And the switching off threshold we set at the consummation level of 200 watts. So this means as soon as 200 or more watts are taken from grid, the heat pump is switched off. We recommend that this window of switching on and switching off is a bit larger than you might think, simply because we do not want the heat pump to switch on and off all the time. Let's go to question number 3, the last one. How to feed in instead of heating. The case is the following. Imagine a customer has a feeding in limit of, let's say, I don't know, 4 kilowatt. And with this feeding in limit, the customer doesn't want the Ohmpilot to be activated in the morning and consume all of the energy in the morning, and then stop heating water at noon. And then when the most energy is available, then there is no Ohmpilot and no self-consumption, and all the energy is going to the grid, but it can't, obviously. What can you do? There are two options. I will show you the first one in our Solar Start app. To be more specific, I will use the inverter simulator. Maybe you know it. This is a free program available for everyone on the internet. It is a dummy version of our Solar Start app or Start application. So you can also use it, you can try it out, and it's a perfect piece for practicing with Solar Start app. This is invertersimulator.fronius.com. Usually you would see here the inverter and the power it is generating. As I said, it's a dummy version. Then you click on energy management, and you see with energy management, I'm asked to enter the customer password. I do this. And so the surface we are at currently can also be done by the customer. Not the technician password is necessary, only the customer password. That's also an important detail. Then you go to self-consumption optimization. There are two options, automatic or manual. And if you click on manual, then you can set in a desired feeding in target. Let's say this target is 3000 watts. This means that the inverter is always regulating in a way that 3000 watts are fed in, and only surplus that goes beyond those 3000 watts is used for every other load management. So your Ohmpilot is only activated if more than 3000 watts are currently available. Also, your battery is only charged if more than 3000 watt surplus is available. Maybe you know this page here, load management, and here you can set the priorities. What load should go first when there is surplus? With this self-consumption optimization setting, imagine there is an additional box, and in this additional box it says 3000 watts. So first 3000 watts, and then the priorities are worked down. When does this setting make sense? It makes sense if your customer has a relatively large PV system. So if he is sure that he often gets more than those 3000 watt surplus, then it makes sense. If the customer has only a small PV system, then he will feed in those 3000 watts and, for example, never get his battery charged. And this will, I guess, not be in his mind. So this is for big PV owners. What can the small PV owners do? There's also a possibility. I will go back to the slides, and I want to show you a screenshot. And this is the production curve of the PV system of a colleague of mine. You see the names is German, but I'm pretty sure you are familiar with the production curve, you're familiar with the colors. So as you know, green is the color of the battery. Doesn't bother us right now. For us, more important is the color red. The color red is the color of the Ohmpilot. In this case, you see that the Ohmpilot is activated at around 11 and obviously has a power of 2000 watt, of course. And those 2000 watt means that the heating rod is a bit smaller than it could be. And this has the advantage that water heating is not done at noon, at 12 midday, but it just takes longer. It's stretched over the day. So the heating rod is activated from 11 in the morning until 5 in the evening. And the amount of surplus, of feeding in surplus that my colleague gets is only around noon and only a little. So if he had, for example, let's say 3 kilowatt feeding in limit, then it wouldn't be a problem. He never has more than, 2000 kilowatt surplus, and he never goes over the 3000 threshold. If he had a bigger heating rod, then maybe water heating would be done at 12, and the rest of the day he has a lot of surplus. So for small PV owners, it could also be an option to use a smaller heating rod. We get to the end of this webinar. As always, the recorded will be forwarded to you within the next days. I hope you enjoyed the webinar. I hope there were useful information for you. If you need further information, I recommend you to visit our YouTube channel. There you find other webinars, also how-to videos. If you're interested in face-to-face trainings, please feel free to visit us at Wels. I'm very happy to welcome you here, and then we can discuss a whole day about batteries, about e-mobility, heating solutions, and so on. My colleague Michael behind the camera just gave me a nod. He said no questions he wanted to share. So I will conclude this webinar. Thanks a lot for joining. I hope you enjoyed it, and see you soon. Bye-bye.